So hello everyone, I am happy to see you again on my channel, and today me with you we will check a new exercise which is called find minimum in rotated sorted array. This task is of medium level, so let's check the conditions and what should we do. So sup suppose an array of length n which is sorted in ascending order and is sorted between 1 and n times. So, for example, we have an array with numbers from 0 to 7, so it's just a sorted array, which might become 4, 5, 6, 7, 0, 1, 2, so it's rotated. Yeah, we moved our elements to left or to right, doesn't matter. So that means that the array is rotated. And our goal is to find the minimum element of this array. And we also have a constraint that we must write an algorithm that runs in all log n times. And below we have some examples. And actually you may think that maybe it's impossible or pretty difficult to solve this task. Actually it's not, it's pretty simple. I just wanna you to pay attention that actually we always have in these arrays two parts where elements still remain sorted, for example like 0, 1, 2 or 4, 5, 6, 7. So array is separated in two different sides where elements still remain sorted, so it's pretty important here. So now let's go and answer to some questions like we do usual in every video. So what are we searching for, why binary search, and what pattern can we use here? Again, I suggest you to answer to all of these questions by yourself because it helps you to better understand the task and what you need to do. I will do it right now, so let's check the answers. So what are we searching for? So we are looking for the inflection point, the only place in the array where nums I is greater than nums I plus 1. At this position, the array breaks its ascending order due to rotation. The element nums I plus 1 will be the minimum value in the array. So it's the same thing which I mentioned before. So we still have two sides in our array which remain sorted. And now let's answer to the next question. So why binary search? So even though the array is sorted, it consists of two sorted subarrays. By comparing the middle element with the right boundary, we can always determine which half contains the minimum. And what pattern can we use here? I think you already guessed, it's a binary search, so a little bit modified binary search, but it still remains binary search. So instead of looking for a target value, we shrink the search space toward the smallest value by comparing nums mid with nums right. So I hope it's a little bit clear for you how the algorithm should work, but I think it will be much clearer when we will start to implement the algorithm in the code. So let's start to do this. So let me a little bit make the size bigger for you to be clear to understand and to see. Okay, let it be like this. So let's start to implement our method. So first of all, let's initialize our method public static int, because we will return the minimum element from our array. And let's call our methods find minimum in rotated sorted array. Okay, and we will have only one argument here. It will be our array, which will be our input, from where we will search our minimum element. So int array. Okay, go. So now let's create two pointers to variables left and right, which will contain index to the left element and to the right element. So let's do this. Left, which is equal to 0, first index, and int right, which will be index of the last element initially. So array length -1. Okay, cool. Now let's create a loop, because we need somehow to iterate through our array, because we don't know how many times we will iterate through our array. We need a condition, yeah. So the condition which will return true in some case and false in another case when we want to stop our loop. So in our case it will be a while, and the condition will be that left should be less than right. So if this condition is true, we will still iterate through our array. And now let's calculate the index for middle element. Yeah, so because we want to take this middle element and to check in which side, from left or right, potentially the minimum element could be. So for that, let's first of all calculate the index of the middle element, which will be left plus right minus left divided by 2. Perfect. And now let's put a condition here. Yeah, so we use an if statement, and here let's check if element from the middle, if this element is greater than the last element from our array. So right, that means that potentially the minimum element is in the right side, so we need to search there. So in that case we will need to change value for left pointer. It will be mid plus 1, and in otherwise, in our case, it means if the middle element is not greater than the last element from our array, it means that the minimum element is potentially in the left side. So we need to search there, but still middle element can be the minimum one. Yeah, so because of that, we will do something like this. So right is equal to mid. Okay, perfect. And in the end, we will return the element to which left pointer will point in the end of our all iterations. So now let's check how this algorithm is working. So let's write system out println. Let's call our method, and here let's initialize an array, and here let's do something like this. So let's initialize this array with this values 6, 7, 8, 1, 2, 3, 4, 5, and that's it. And now let's check how does it work. So the minimum element in our case is 1, so it should be 1. Okay, cool, so we have the correct answer. Now let's go back. So now let's analyze our algorithm, our solution. So the time complexity is O log n, how it was required in the condition. So we divide the search space in half at each step, Even if the array is sorted, we only perform algorithmic number of comparisons. Okay, cool. And the space complexity is O1. We only use a few pointers, left, right, mid, regardless of the array size, so no extra memory is allocated. So I think the complexity is fine. So thank you for watching this video, and I hope we will see in the next video. Bye.